My vision is a future for humanity where we'll be completely free to pursue activities outside of our planet.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
Oh, yeah, baby Franklin. Chang-Diaz.
Not the Jamie we all talk about.
That's a hell of a first name.
Yeah, well, of course, he was our astronaut of the week quite a long time ago. I don't know what episode it was, but I do remember talking about him. How prolific is he?
Well,
He's been on STS 61, 34, 46, 60, 75, 91, 111. That's a lot of space shuttle
yeah, but
flights.
this is what happens when your first name is Franklin and you're a Costa Rican Chinese American astronaut and physicist. How'd you like them apples?
And the inventor of the variable specific impulse magnetoplasma rocket.
Yeah, but who hasn't done that?
Or Vasimir, which we've talked about several times because it might be the way to get around the solar system.
I'd like an on this day, please.
It's Franklin Chang-Diaz's birthday.
Oh, what? Happy birthday, Franklin.
This is another of his quotes. He says, for decades, people have known the chemical propulsion approach to space travel isn't going to get us that far. Chemical propulsion is essentially the horse and cart approach.
I like it. Old school.
Well, new school, I would say.
New and old school.
He is both old space and new space.
Yeah, man.
Do you know a little bit of a sadder one, this one, on this day in 1991.
Go on.
We're talking about the 5th of April, of course. There was a plane crash near Georgia, in Brunswick,
right,
that killed 23 people, including Senator John Tower and STS-33, the space shuttle, the one before Franklin Chang-Diaz's, Sonny Carter.
Oof.
Astronaut Sonny Carter died in that one.
That's not good.
And today would have been the birthday of my old lunch. Well, I had supper with Donald Lynden-Bell a few years ago. And of course, he died last year. We mentioned this on the podcast. And he was an amazing astrophysicist and astronomer.
Absolutely was.
In the field of black holes. And it's his birthday today, or would have been his birthday today. But I wish to celebrate it. Happy birthday, Donald Lynden-Bell.
Happy birthday.
You know what? Last week we were possibly being a little bit harsh about the NASA announcement.
Yeah, we were.
Going back to the moon for 2024. It's quite funny. I listened to the much more optimistic version by Anthony on Main Engine Cutoff podcast. Bridenstine actually reiterated this. He actually sort of said, this is a big change and it comes straight from the top. It's a once-in-a-lifetime opportunity. And I agree with that.
It is.
I'm slightly less convinced, I think, because for me, it seems like the whole thing is slightly less focused now, because they took a few weeks ago, we were talking about how they were sort of talking about using commercial spacecraft to do the job of SLS for the first few missions, and they've completely rode back on that. Now they've realised it's impossible, and for me, it's like they're kind of thinking out loud. It's like they're doing this thinking in public at the moment, where they're just going, can we do this? Well, let's just say it out loud and see if it's possible. And it only took a week for that one to unravel. And you wonder how long it will take for this one to unravel, because they're sort of saying by any means necessary. And the interesting thing that Bridenstine's been talking about this week is that you could use a Falcon Heavy using a United Launch Alliance upper stage, which to get to the moon. That would be feasible. That you've got enough throw, as you like, to get the Orion capsule to the moon. So they've also been thinking about it. But Gerstenmaier, the head of human spaceflight at NASA, is totally unconvinced because it's really hard to integrate Orion with the Falcon Heavy, particularly considering Falcon Heavy is horizontal when you're putting it all together, and then you've got to put the Orion on top.
That'll do it.
And then fuel it in a vertical position. That's difficult. And then you've got to put this much bigger fairing the Falcon Heavy that puts this massive stress on these two ridiculous side boosters that it has. So yeah,
It's left a bit of a sour taste in your mouth, hasn't it, Matt?
It's not a sour taste. It's really exciting. It's really exciting. Don't get me wrong, but it's like they're thinking out loud and putting all these things in, and I think that makes it less focused. It would have been better if they'd been having these chats and looking at this sort of stuff behind closed doors and saying, God, yeah, this is possible. Here's a bunch of options that we're now looking at, rather than going, yeah, let's go to the moon by 2024 and let's hope somehow that there's an option for that to actually happen. At the moment, we don't have a rocket that will get us there. We actually genuinely don't even have a rocket that will get us there. And we don't know what rocket it's going to be. We don't know whether SLS will be ready on time. We don't know whether Falcon Heavy would actually work. We don't even have the contracts out to start designing the lunar lander. And you heard me right, designing it, not building it, designing
this
it.
This is the key word, yes.
But my biggest one is we don't even know why we're going there. What's the mission? What's the mission? It can't be just to put feet back on the moon.
No,
can it?
It's not, like we said last week, it's not going to be playing golf again.
Yeah, so what's the mission? What is actually the mission? That would be much more exciting for me if we said, right, this is the mission. And even more obvious is the fact that the lunar gateway is being talked about less. So has that gone off the table now? It seems to me that there's more confusion. It's less focused, and that cannot be a good thing when it comes to space exploration. A lack of focus.
That's especially for the people involved in the bit of the construction and design. They need to know that they're doing this for a reason.
Yeah, I would imagine that working at Boeing and working at NASA and working at SpaceX must be a very weird time at the moment, because it's both exciting and stressful, because it's like all the cards have been thrown up in the air. It's like, well, where's it going to land?
It's a little bit like being a co-host of the Interplanetary podcast, exciting and stressful.
I don't think you've said anything such a fine analogy ever.
Good luck to them.
I did notice that the members of the House Science Committee were also sceptical of the crash program to get humans to the moon by 2024. But Jim Bridenstine hit back and said, don't worry, I'm going to have the costs of the accelerated program ready for the middle of the month. So we'll see how Jim Bridenstine, what the kind of new request for budget is there. So interesting times. I've
got my calculator at the ready.
A couple of weeks ago, Jamie, we mentioned that Starliner was going to be delayed. The test launch of Starliner.
What's the latest?
Well, the latest is that has been confirmed due to congestion of Atlas rockets on the launch pad.
It's not like the Gatwick runway. I mean,
but there we go. Delayed till August, but it does mean that they still have just about enough time to achieve a 2019 crewed launch, which would be 4 or 5 years late?
I think it might be.
Which doesn't bode well for getting to the moon for 2024, does it?
This is your pilot speaking aboard the Starliner. We have a few passenger planes ahead of us, and we'll be right on our way as soon as possible. Thank you for your patience.
Did you know that it was Chuck Yeager that invented that way of talking?
Was it?
Yeah, Chuck Yeager kind of is like really influenced pilots to talk exactly like that. That's where that came from, Chuck Yeager.
That's quite interesting. I like the way it's quite passive aggressive when they say thank you for your patience, because they're assuming that you're being patient with them, aren't they?
You better be patient, and I'm thanking you for being patient, but if you're not patient, screw you.
It's like when you get asked for money by people who say thank you in advance for your kind, generous donation.
That's like you in your marathon running.
Yeah. Matt, you need to sponsor me.
True.
It just reminded me. You stitched yourself up.
Yeah.
Hoist by his own petard.
I tell you what, we'll do a non-space tweet for the first time ever to get people to sponsor the host.
Oh my goodness! Could we do that? Hey, for everyone
we can.
who doesn't know, I'm running in 12 days' time. I'm going to be running 26.3 miles, all in the aid of a wonderful charity that I'm a trustee for called Smart, which is a mental health charity based in London. And I'd bloody love it if you could give us a couple of quid or dollars or wherever you live to help out for the good cause. That would be lovely.
You the man with wobbly legs.
Oh, they are going to be wobbly. I'm going to need a rub down.
You'll probably at the end of it be expelling quite a lot of methane.
I see what you did there, Matt. That is a seamless link.
Yeah.
Genius.
Seamless. That's even more seamless.
What?
Because it's obviously cracks in the seams of the planet that may be releasing this methane gas.
Ah, yes. And this is one reason why Elon said he didn't want to blow it up, right?
Oh, God knows what
Let's
Elon's
not go.
up to.
Let's not go back on that.
But what's brilliant is that ESA's Mars Express has been able to verify for the first time Curiosity in 2013 picked up a huge stink of methane. It went, and could smell methane. So that was really exciting, and everyone was going, well, it could be methane, but Mars Express, they've reanalyzed the data from Mars Express from that period and have been able to, without any doubt, say, yes, it was methane that Curiosity was detecting. So we've pretty much had very strong confirmation that there was a big release of methane into the Martian atmosphere around about 15th of June 2013. Which, of course, is very exciting. Methane being very trendy right now.
It really is on fleek.
Yeah, not just for propulsion, but for the biosignature of life itself. It might be. But, of course, geological processes also release methane into the atmosphere.
This is true.
So here's what Marco Giarana from the National Institute for Astrophysics in Rome, Italy said. He said, in general, we did not detect any methane, aside from one definite detection of about 15 parts per billion per volume of methane in the atmosphere, which turned out to be a day after Curiosity reported a spike of about 6 parts per billion.
6 parts per billion?
6 parts per billion.
I love it.
He's the lead author of a paper in Nature Geoscience. That's all. A few papers have been released this month in various journals about this methane on Mars and the ExoMars backing it up. So there was a couple of studies that they did to try and work out where it was coming from. So the Royal Belgian Institute for Space Aeronomy in Brussels applied computer simulations to create 1 million emission scenarios for each of these squares that are in a grid. So they divided up Gale Crater into grids of about 250 by 250 square kilometres.
Right.
That's how big Gale Crater is.
Wow.
It's mad, isn't it? So they've been running computer simulations for emission scenarios in each of those squares. And these simulations took into account like the measured data, the expected atmospheric circulation patterns, and methane release intensity and duration based on the geological phenomena of gas seepage, something that you know really well, I know.
Oh, completely.
You're an expert.
Yeah.
But there was a second study as well from the geologists at the National Institute of Geophysics and Volcanology in Rome, Italy. The Italians are all over this,
They really are.
And they were helped by the Planetary Science Institute in Tucson, Arizona. And they've been scrutinising the region around Gale Crater for features where gas seepage is expected. And Marco says, remarkably, we saw that the atmospheric simulation and geological assessment performed independently of each other suggested the same region of provenance of the methane.
Ooh.
So that's pretty cool, isn't it?
Very cool. I love that.
They're homing down about where this methane is going to come from. There's still quite a few unanswered questions, like how does it get removed from the atmosphere, for example? and how often are these events, etc. But the great news, of course, is that we now have ExoMars that has been now operating for just over a year. And hopefully that's going to hone in on that, and we're going to get some really, really interesting results about where this methane is coming from. Could be microbes, Jamie.
I tell you what, I'm not going to get too excited, but we will get to the bottom of this. Excuse the pun.
Well, yeah, and we can answer David Bowie's question: is there life on Mars?
I keep having these dreams, Matt, about Europa, so I don't care where it comes from. It's going to find us.
Well, Jamie, what have you got to say for yourself this week?
Well, I've been looking up about weird objects in space, Matt.
As you promised last week, to be fair.
I know, I did promise it last week, but I've been looking into it again. And I mean, there's a couple of interesting articles that I read, and I just thought I'd tickle your fancy, Matt. See what you think about a few things.
Okay.
As you know, lots of different companies send different things into space. But did you know, for instance, Matt, that Pizza Hut spent £750,000 in the year 2000 to send a pizza to Russian cosmonaut Yuri Yusakov when he was up on the space station. Did you know that?
Now, here's a question for you. Do you like cold pizza or reheated pizza? Which one?
Well, I like it fresh, but if it's the next day, I like it cold better.
Yeah, I'm with you. I like it cold better. What do you think Yuri did?
Oh, I've got a feeling he heated it up, because I also found out lots of things I didn't know, that there was an oven on the space station. I mean, you just don't think about these things, but of course. I thought it was just hot water, reheating up their macaroni and cheese and the like. But
and that terrible ice cream that you get.
And the terrible
space ice cream.
Dry, powdery ice cream. Yeah. But they also sent some records up to space, Matt, with hundreds of different ways of saying the word hello. Lots of different languages. 2 gold records.
Surely these are the gold records that are on the Voyager.
Yes, you are absolutely right. It's on the Voyager. And apparently Carl Sagan said that he hoped that the records would only be played if they're advanced spacefaring civilizations in interstellar space. He doesn't want us playing them unless we meet these intelligent aliens, Matt.
It's such a long shot, the Voyagers. The thing is that they've gone into interstellar space, but interstellar space is just unimaginably huge.
It's pretty big.
And going at chemical propulsion speeds, it's just pathetic.
I know.
They're still only... They're not even out of the Oort cloud.
I got upset about the amount of dead monkeys that there are in space. Most of them apparently named Albert.
I thought all the monkeys that went into space would have burnt up in the atmosphere by now, which I don't know whether that's better. But so you're saying there's actually literally like monkeys still out there in orbit?
Monkeys floating around in orbit.
Oh my!
I mean, imagine seeing that on the space station. I don't know. I need to look into this more.
Oh my gosh!
Isn't it awful?
Now, Jamie, I've got one for you.
Go on.
Do you remember the Doritos commercial?
Oh, I do remember.
That was beamed out to the plough, as we call it, or the Big Dipper, as our American friends call it.
They love a pun, and the Big Dipper.
Do you know what? I've only just got that.
What? That's why they chose it.
I thought the reason why they chose that particular, because it's 47 Ursa Majoris, isn't it? Which is in the plough. And I thought they chose it because it's a very similar star system to ours that probably has planets like ours. And so it's one of the sort of nearest places that they knew at the time, because this was way back, something like back in 2008, wasn't it?
But Matt, I'm afraid you're wrong. The advert was actually about them releasing their dipping sauces. Hence,
yes, I know
Big
that.
Dipper.
I didn't. Do you know what? Oh man, I can't believe.
There you go. I've
missed
blown your
that
mind.
pun.
How have you missed that?
I know, that has blown my mind. Can you remember the actual advert though? Because I can remember what they actually sent, because they actually wrote it, because it was a British thing in collaboration with the Leicester University. So I'm not even sure that, do the Americans have Doritos, or do they have some other kind of?
Americans have Doritos. Yeah.
Yeah. So, but this was a British advert. This was.
I
This was
didn't
like a
know
sort of
that. Well, we'll have to. Maybe we
yeah.
should contact Doritos and find out the details.
You make it, we play it. So it was user-generated content that they sent, and the winning one was this really weird animation of Doritos all dancing around a glass jar and opening the jar themselves and dipping in, and then the bloke opening the jar and finding a Dorito already in there.
Yeah, the key word there is dipping in.
Yes. You've belittled me enough about
The
this.
point is, Matt,
Sorry.
the point is that do you think we're going to get some free Doritos now?
I hope so. We've said Doritos quite a lot.
We bloody should do. So that's a fantastic one. We will definitely look into that. But Matt, Luke Skywalker's lightsaber after Return of the Jedi in 1983 went up, and I love this one. Clyde Tombaugh or Tombaugh, who discovered
Clyde
Pluto
Tombaugh,
in 1930? His ashes went up on New Horizons.
I did know that one. Yeah.
Yeah, his are the furthest remains to travel
Of any human
ever. One of my favourites, Matt, was a prank, and I do know about this. This is a fun prank, bit of hijinks. In 1965, December the 16th, astronauts Walter Schirra and Thomas Stafford managed to sneak up bells and a harmonica. How'd you sneak that up onto Gemini 6? I don't know. But before re-entering Earth's atmosphere, they reported an object in polar orbit that was a command module and 8 smaller modules in front, or Santa and his reindeer. They went on to say that the module was wearing a red suit. Stifled by their laughter, they began to play the Christmas song Jingle Bells. And that was the first time it had been played in space, Matt.
Yeah, well, I'm going to pull you up on your as I was pulled up by your pronunciation of Walter Schirra.
Oh, here we go.
Who we called him Walter Schirra when he was our astronaut of the week. But it's Walter Schirra.
I did know that, Matt, but I wanted you to feel better about your Doritos faux pas.
Okay. Jamie.
Yeah?
There's no space word of the week this week. Because this Alan Bond interview, Alan Bond Part 3, is a big one.
Oh, here we go.
What I'm going to do with this one is I'm going to edit it down. It's going to be like some really good bits on this one, but I'm going to put a big chunk of it onto our Patreon feed. Even if you're not a Patreon, you can go over to our Patreon site at patreon.com/interplanetary and play the rest of the interview with Alan Bond, because it's mind-blowing. He's so cool. And do you know what's crazy? I went for a drink with one of Alan's friends the other day because he lives in the same village as me, bizarrely. And he goes, well, did you ask Alan this? Did you ask Alan this? And it's like, no. And it's just like, what? So there's loads of things I've not talked about Alan that I need to talk to him about, because he's got things like a computer program that has broken the Turing test, according to Alan.
What?
So and stuff like that. So that's just a little teaser of maybe Alan Bond Part 4 that I'll hopefully do one day soon.
OMG. Well, there we go. And as Matt said, a huge shout out to our Patreons who, they get this kind of extra data from us.
Yeah, well, the Patreons made it possible. They paid for my train fare to Alan Bond's house.
Get in.
Thank you very much. This interview would not have been possible without you.
God bless you.
So
let's roll it.
Écoutez.
SSTO, in my mind, has got very many advantages, because if you have a look at aircraft operations at a modern airport, I mean, it is so slick. The vehicle comes in, they throw all the passengers off, they sweep it out, and sort of maybe put some fuel in if they have to. Minimum checks, and then load the next lot in, and it's off again. And turnaround on an aircraft these days is down to a couple of hours, something like that. I'd like to see space move in that direction as close as it possibly can. The idea that your rocket's going to arrive at an airfix kit at the launch site, and you've then got to put the whole thing together with hundreds of people, it's it's not just that. You've got to make sure that when you do things like that, you put it together correctly. The quality assurance and everything involved in just ensuring that all the right plugs are in, that they've all gone into the right sockets, that nothing's been left undone, that somebody hasn't made some part fit that wasn't quite right, and so on. Because that's what causes rockets to fail. And the cost of all the manpower to do that, because it's not just a question of the guy out there tightening it up. When the guy does a job in putting a rocket together, he has to sign off that he's done it. Somebody has to check that he signs off correctly, that he's done it. And so you finish up with this massive cost. The cost out of the HOTL work, this was back in the 1980s, when the space shuttle was new and it was in operation and so on. Just the cost of taking the payload and putting it into the space shuttle was $6 million. That was just the cost of interfacing the payload with the vehicle. The actual launch cost of the vehicle, all of the preparations, getting the bits to site, assembling it, wheeling it out, standing it up, even though they'd got the actual launch crew at the time down from, I think it was something approaching 20,000 for the Apollo program, and it was down to about 6,500 people to launch a space shuttle. Nonetheless, a single launch of a space shuttle was $750 million, and that was back at the end of the 80s, early 90s. And that's just the recurring cost. Now, how can you, if you went to the British government and said, I've got a program of national importance which is going to have real social feedback, I need $750 million to do it, they'd laugh you out of the place. And yet this was the cost of every single shuttle launch, and they did over 115 of them in the end. So to me, getting space to the point where you've got a vehicle, essentially the last flight was the checkout for the next flight, which is how aircraft work. It's got redundancy so that it can fly with a subsystem down or whatever. And that it's still got to be regularly maintained. And we're in the very early days of all of this, obviously. One would like to feel that by the 22nd century, all this will be old hat, same as aircraft are now. But there are so many reasons why you don't want this a vehicle arriving. We've got to stand it up. We've got to fill it with propellants. Everybody's got to be in the blast shelter while we're doing it and so on. We need to get away from all of that.
So dare I say it's about making space boring and routine. And
so
reliable.
Bob Parkinson was the first one I recall sort of making a statement like that. To me, Antarctica is the model. So somebody's bit of radio kit in Antarctica fails. There's a Hercules on its way down there on a routine flight with his next piece of kit on it. How many times do you hear politicians sort of on their high horse in the Commons saying we should pull out of Antarctica? It's too expensive. Antarctica is not political. Well, it is in some senses as to whether we should be exploiting it now. But there are no Commons debates about the cost and the operation and all that sort of thing. It's below the noise, and it's not in politicians' interest to haggle about it. I'd like to see space like that.
Can you not have a boring two-stage vehicle? Isn't say something like Falcon 9 Block 5 approaching a boring two-stage vehicle?
So the nearest I think that we ever saw that, if you go back to the late 1960s, early 70s, sort of pre the American space shuttle that we actually got, this was the two-stage aeroplane, and that, from what I've seen on two-stage vehicles, that was the closest we got to having something that could approach boring operations. They simplified the way that you'd assemble those vehicles. What I find astounding is that the Americans in that time developed all the engine technology. The SSME that went into the shuttle that actually emerged was the engine that was needed to make that work. They got right on top of all the aluminium airframe technology. With a two-stage vehicle, they would have been able to have a more robust thermal protection system than those damn tiles that they finished up with. Throw away the solid boosters so that we're not having to sort of drag those things out of the ocean and refurbish them. And it did seem to me that the Americans have got all the technology at hand to do that. Now, in keeping with many changes in economics across the rest of the world, Elon Musk, who I've probably said before is to me a hero, he's actually come up with a method of doing this. I don't think it's a safe method of recovery that he's got. And one of the things, the horrible things that I think are waiting downstream is when one of those boosters arrives back at the Cape and its braking engines don't fire. And that's going to produce, if it's from a Falcon 9 Heavy, he's only got to have one booster fail. It's going to take the other one out spectacularly as well. So I don't think it's a safe method of recovery, but he's broken the mould. At least he's now reflying hardware. I haven't personally seen any figures as to how much the refurbishment's costing. So the space shuttle, for example, the Americans made a great big publicity argument out of the fact they were getting the solid booster cases back. But in reality, when they got those back, they were stripped right down, they were disassembled, they had to be corrected on shape, retested for flaws and defects. So it probably cost as much as if they just made new boosters. But obviously it was as politically very expedient to demonstrate to the world that the space shuttle was a semi-reusable vehicle and that the boosters were reflying. I've not yet seen any figures with regard to how much refurbishment SpaceX is having to do on the boosters that are reflying, and whether they're managing to keep the same engines and so on. That's probably my fault. I've just not been following the literature. The figures may actually be out there, but I'm not seeing it.
Yeah, I mean, they're supposed to be trying to get the Block 5 down to a day turnaround, but of course they're nowhere near that. I mean, if it was you could clearly see if it was the next day they had it back on the launch pad, then they can't have done too much refurbishment. So
I don't know who are the actual engineers behind the recovery, but they are very good. There's no question about that. They've made a system work. The concept's been in the literature for very, very many years, and in my own personal archive, I've got original handwritten notes from Philip Boner of the old Douglas company, in which he was advocating pretty much what SpaceX are doing a long, long time back in the. My notes go back to the 1970s. So the concept's not new, but the flaw that everybody saw in it is what happens when the braking engines don't light when it comes back to the Cape, because there's a lot of propellant on that vehicle to decelerate it. And LOX kerosene, for example, excuse me, is over 1.4 times the explosive yield of TNT. So that's a big bang if it fails to decelerate.
Yeah, I mean, it's already smashing windows, isn't it, as it comes back through just on the sonic boom. So.
The thing is, in media terms, it seems that SpaceX have really captured people's imagination. So it's it's spectacular stuff to watch. Whereas if you think about SSTO, it's not going to be as spectacular to watch, not in the same way that vertically launched and vertically returning rocket is.
But come on, all of us like to go and stand and watch a steam engine go down the track, whereas one of the high-speed trains is seriously boring. I mean, what are we all turned on by? Lots of steam and flames and soot. Whereas something that just goes swish is how can you get excited about that?
Well, I still go to Heathrow Airport with my kids, and we just watch the plane take, and it's just great.
It needs to be not boring exactly. We just need to be able to make sure that it is not a seriously captivating activity.
Yeah. I think what I meant was rather than boring, routine is probably the
routine's a good word.
Is the thing.
But as I say, our old colleague Bob Parkinson was the first one I think I heard sort of say, we want to see it boring. Bob and myself often have had discussions in the past of that.
Do you think, if we get closer to home, do you think that ESA and Ariane missed a trick with Ariane 6 in not even contemplating reusability as quickly as possible on it?
I don't want to knock the poor old European Space Agency, but when it comes to access to space, I really feel that they could do a lot better. The Americans can turn around a whole new launch system in a fraction of the time that the European Space Agency can, and it's hard to see why. We just seem to spend far more time debating and deliberating over stuff. The generation of launch vehicles that's just gone, the Atlas V and the Delta IV, Heavy Delta, etc. The Americans turned that system around and produced it in well under 10 years. And yet Ariane 5 was 20 years in gestation. And I just don't know why it takes so long in Europe to do anything relative to the Americans. And yet quite a lot of stuff that we do in Europe is done cheaper than the Americans, despite the fact that, we've mucked about for a long time deciding what it is we're going to do. We don't seem to be able to make that decision. Elon Musk, I can't balance Elon. I've tried very hard to balance the books and understand why SpaceX can do things apparently a lot cheaper than anybody else. And I have to conclude that there is something not in the public domain about the funding of SpaceX. It just doesn't work. I know that a lot of enthusiasts have sort of said, well, you can alter these figures. And yes, he bought out Vought Aviation for whatever it was, a fraction of a dollar or something. And he got access to all the fast track program engine hardware. But even when you take that into account, you cannot make the accounts of SpaceX actually work. But nonetheless, in terms of getting things done, to go from a standing start to flying a Falcon 9 in about 5 years, that is very impressive. The only more impressive thing that I know of is back in the good old Cold War years, was the Douglas Thor missile, which went from a standing start to the first one on the pad in 11 months. Now, how do you do that? It's very impressive. It didn't work, but 2 months later it did. So in a tad over a year, you've gone from a standing start to having a vehicle. In that case, it's a missile, but a vehicle actually flying.
Maybe that was the Cold War. The impetus was, the focus was on producing.
So I think that's amazing that Musk has managed to achieve development timescales which previously could only been achieved by governments under Cold War type pressures. So I think when it comes to looking at things like Ariane 6, I think a lot of introspection is necessary to try to find out what it is that keeps these things dragging on so long. Is it just a question of funding? Back in the good old days of our ELDO program, of course, the real problem there is that it never had a unified organisation. It was all done by individual governments doing their own individual bits, and all the individual civil services trying to communicate. And as a consequence, not only did it drag out, but it never produced a successful mission to orbit. So this side of the Atlantic, we don't seem to be able to move the same way that the Americans can. My own experience in trying to get reaction engines and the Sabre development and Skylon, the shareholders have been absolutely magnificent. I can't in any way fault the private investors that have done that. The government, of course, did finally come through, but it took the government 3 years to finally release the money that David Willits had decreed and George Osborne earlier. So 3 years just to release the money. So there is an issue this side of the Atlantic which the Americans normally don't suffer from. I say normally because when I then look at SLS and Orion, I mean, they're getting bad habits from Europe, I think, when it comes to those systems.
Yeah. So, I mean, do you have a theory about what that bad habit is? How does that creep in? How have America basically caught the European disease?
I really don't know. One of the great things about Elon Musk and going back in time to Korolev in the Soviet Union, you've got a guy who says, this is what I'm going to do. And the engineers all come forward and say, but, and they don't want any buts. That's you're going to do it. I've said it. You just go and do it. Make it, test it, get it done. And Elon Musk and Korolev have got quite a lot in common from that point of view. You need somebody at the top who's just going to say, this is how we're going to do it. Get on with it. And then other people will say, well, we ought to do some optimization, never mind the optimization, just go make this work. And so looking back in time, that's very much how things used to work back in the immediate post-war years and the 1950s and so on. But to some extent, I think we're all blighted by the idea that we can't have something that breaks on the test stand. We've got to go away and we've got to design it to death. We've got to analyze it into the ground, and then we're going to put it on the test stand and it's going to work first time. It doesn't. But that's the principle, the idea that you can't have failures during a development program while you're building equipment. But,
is it something to do with maybe that the shareholders themselves aren't passionate enough about the project that they get scared too quickly?
There's very much an element of that, I think, in that projects tend to be progressively funded. You've got so-called milestones. And so projects now are broken down into a long time scale with intermittent milestones so that you can achieve that. And then everybody's got the confidence to put the money in to go to the next bit. Whereas, as far as I can see, that in terms of SpaceX achieving this really tight time scale, they had a milestone with the Falcon 1. And it took them a while to get that to work. But as soon as they got the Falcon 1 working, Falcon 9 was straight into it. Not a load of intermediate development programs and so on in between. Once Musk realized that I think it was a very close run thing. If the Falcon 1 hadn't finally succeeded, then I suspect that SpaceX wouldn't have gone on. But Falcon 1 sort of finally did it. And then the time scale after Falcon 1 to Falcon 9. And I mean, Falcon 9 in many respects is just sort of 9 times Falcon 1. And so that's been a success. This breaking down everything into intermediate steps, and we're not going to fund the next bit. It wouldn't be so bad if the funding was already in the pipeline waiting to go. But it isn't. It's a lot of committees and decisions, and then start worrying about how you're going to put the funding in for the next time. I think with the Americans and NASA at the moment and the SLS, I think it's lacking an objective. First of all, it was going to be return to the moon, then it was going to be Mars, and then it might be return to the moon, and then it might be to go and have a look at an asteroid. And one of the things that is really death to a program and pushes the cost up dramatically is when you can't make your mind up and start changing the specifications and so on.
So you've got to have an overriding purpose and be focused on that.
And I think that I perceive that the Americans don't have that at this point in time. Yeah, there are a lot of ideas, and obviously there's now a lot of issue about the gateway sort of route, which I don't think has got many enthusiastic supporters for it. The great thing about Apollo is that Kennedy gave the Americans and said, we're off to the moon, and 1969 they did it. And one of the things that one has to remember about 1969, that was only 25 years after the V2. And 25 years later, you've got people actually on the moon.
Yeah.
And
it's barely 65 years after the first aircraft.
Absolutely.
It's
That
incredible.
to me is one of the most staggering technological progressions in human history, from the Wright brothers to Apollo 11. It's just staggering.
And you look at Saturn V and you think, well, is SLS really that much of a progression from that?
So I think that a lot of people sort of asking the question, why can't you just get the drawings out for Saturn V and dust it down and sort of bring some of the technology up to date? And we're back to Korolev, you see. A lot of people would say, but we can do so much better. We've got all these super materials and so on. And if Korolev was in the room, I'm blooming sure that what he would say, never all that, just go and do it. Get the drawings out, change the electronics, because that's where the big changes have taken place. But everything else, just make it the same. But I think it's very, very difficult to know all the detailed reasons of why we just can't move on these things these days. Why, obviously, with reaction engines, when I was running the company, I can see how a little bit of inertia spills over, something gets delayed, other people get delayed. As soon as that happens, actually, you can see the weeks flashing by and nothing happening, especially when you get onto test stands. That's where when you've got a piece of equipment that won't function, or and that's where you've got to put the engineers on it. You need a very quick turnaround with your workshops in order to get something that isn't working and so on. And we did manage to achieve that when we did the pre-cooler testing at Reaction Engines. We got a phenomenal response from our workshops within the company and so on. So we'd do something in the morning, find it wasn't right. Back in the afternoon, the components would be back in there and we'd be back on there again by the end of the day. And that really, really worked. But one can see how once you've got programs with decision points, etc., as I've already said, I think the reasons are very complicated, but it amounts to a system just having an inertia that hard to get around.
What about the sort of risk-averse culture? The sort of the proverbial health and safety aspects of it.
So health and safety has had a dramatic impact on how much it costs and the difficulties of getting something done. I'm very much in favour of health and safety, but I do think that health and safety, as it stands, not only in this country, but pretty much across all of Western countries and probably into the ex-Soviet bloc countries these days, is a real drag anchor on getting things done. And a lot of the things that I see in health and safety, I don't think are absolutely essential, or do I think it puts the risk to people up. Health and safety these days seems to go beyond just human health and safety, but economic health and safety. So the possibility that you might damage test facilities, for example, if you have a failure, you've obviously got to have an eye on that. But any competent designer is actually building that into their work as they go. You do not need a separate committee looking over their shoulder, sort of inquiring into every bit of it. You've got to devolve some of the responsibility onto the people actually doing the design and manufacture. Whereas there are now whole separate organizations with volumes and volumes of material, codes of practice, best working, etc., in order to avoid even the slightest possibility of a mishap and somebody getting hurt. There's lots of examples spring to mind, but it would be boring to go into it. But just the use of quite a lot of substances in daily use in companies and so on, where there may be, if you don't use respirators, etc., some possibility that you may, and the work's still going on. Many years ago, I won't say which organisation I was working for, but we had to braze up some copper samples, and these copper samples required a silver brazing medium, and the flux that was required was pretty toxic, and the organisation wouldn't even allow that flux on site. So I did it in my oven in the kitchen in order to do the brazing samples. I would claim it's not affected me. Other people might disagree, but with all of these things, there's got to be common sense, and sometimes I don't feel that that is in play.
Yeah, often it's the misunderstanding between hazard and risk, isn't it? It's just like you go, it's not a risk. It was a hazard.
If you lie face down in 2 inches of water, you die. And obviously, people don't do that, we all still manage to take baths and go to swimming pools and manage that quite successfully.
Yeah, we were talking about single stage to orbit and test stands, and you sort of mentioned that. So some of our listeners are interested in the kind of roadmap of the Sabre engine. I know that there's a couple of test stands now that have been, one in America, one over here. Can you tell us a little bit about where we're at with the Sabre engine, which is...
Yes, so obviously I'm now retired from reaction engines, so I'm not actually speaking on behalf of the company, but I'm sure that they don't mind me saying what I can about those programs. So in the early days of reaction engines, the big reason for doing the Sabre engine was to enable the Skylon spaceplane. As we've gone on and refined all of the thermodynamics of the cycle, we realized that these engines have got much wider applications than just spaceplanes. There are substantial terrestrial applications for all kinds of civil and potential military applications. So what the company has done in recent years is, in recognition of that, is focused on trying to demonstrate that the Sabre engine technology is all viable. It's all viable in computer modeling and as much engineering, common sense and so on as you can put into it. But the next step is to actually get some of this hardware on test. There's no new physics in a Sabre engine. In fact, most of the physics is over 100 years old. But a lot of the hardware is now being enabled by new technologies like additive layer manufacture and so on. And some of the heat exchangers and so on a Sabre engine are a real serious challenge. We're talking about very tiny passages, about the same sort of size as the passage in your lungs, the alveoli in your lungs that enable oxygen to be absorbed by your bloodstream. And we've got to manufacture that. It's great with lungs, of course, they grow, but we've not actually managed to achieve that with a Sabre engine yet. So there's a whole development program on technology, a very expensive program. And then that equipment's obviously got to go on test. And as any engineer knows in this field, we're pushing temperatures, power densities, stress levels to their limit. And inevitably, that testing program is going to have its failures, anticipated failures that have then got to be corrected. So reaction engines at this point in time is focusing very, very much on demonstrating all of that engine technology works. And when they've done that, then not only the Sabre engines for Skylon are going to be possible, but Sabre engines for Mach 5 aircraft to travel around the world, smaller vehicles than Skylon, which would be able to, with the help of an upper stage, but smaller payloads into orbit, but in particular enable a space infrastructure. So Skylon is really just the first part of an infrastructure, which, in my view, would eventually span all the way out to the moon using permanently space-based vehicles. So if you go back to some of the writings of von Braun and the British Interplanetary Society back in the late 40s, early 50s, then it was never all about a single shot to the moon like Apollo. It was always about having a way station. And a lot of the concepts that have been developed since that, with resonant orbital vehicles with suitably placed propellant depots, regular fueling, etc. I think that that's where that will go. Coming back to reaction engines is trying to get the first of its demonstration engine technology on test, probably 2020. Almost certainly it will span 2021, 2022. Meanwhile, there is a part of Reaction Engines in the United States, Reaction Engines Inc. Its chief executive, Adam Dissel, is a very experienced guy. And they've built a second test facility there, which is a high temperature gas supply using a jet engine with reheat to supply air at the right temperature into a pre-cooler, which has got all of the helium cooling, etc., in that, and that's currently on demonstration even as we speak. So it's moving on, but it's a very demanding program from the manufacturing point of view.
I presume it's complex politically with dealing with the American side of things and DARPA involved.
It has been very complex, and at the moment, it's not especially complex in that particular area. Now, there are complexities in any technology exchange with the Americans these days, because they are extremely covetous of their technology, but also I'll use the word paranoid in the nicest possible sense, that this technology is going to find itself into the hands of people who are not particularly friendly towards America. And as a consequence of their very covetous control of that technology, it makes working with the Americans actually quite difficult. And so one of the reasons that Reaction Engines established its own company on American soil is to try to overcome some of the difficulties that would otherwise be very hard to overcome.
But presumably it goes both ways. You don't want technology leaking out of.
So
I guess.
It's not just the Americans we have to be careful of. There are other nations on the earth that would desperately like to get hold of the technology. The principle of Sabre engines is out there. Most people can go away and look up the stuff that's been published in the past and know how it works. The real problem with a Sabre engine is making one, and the technology that has had to be developed to produce the pre-coolers, in particular the control over processors has been very, very hard won. So we're dealing with materials working very close to the physical limits that those materials can operate at. And if you get all the process control wrong, then you can ruin the material even during manufacture, let alone during its operation in the engine. So that's really where the important bit is, and it's keeping that process information very tightly to Reaction Engines' chest. That's the point. There are patents now out there, and so patents are obviously double-edged instruments. On the one hand, you seek to prevent somebody else taking your ideas. On the other hand, as soon as you produce a patent, you tell other people a great deal about what it is you're doing. So it is moving forward. It has to be done very competently, and Reaction Engines has got now a lot of people making sure that they control the intellectual property and make sure that it's well monitored to be certain that other people are not getting their hands on it one way or another.
Is that something that someone really keeps an eye on in terms of, say, because there's rumours that China have a similar or trying to work on a similar capability. Are there systems around the world that you know that are maybe potential competitors to the Sabre system?
We know that various companies, and we know that the Chinese themselves have got a strong interest in Sabre technology, and have had for many years. For very good reasons. I mean, China is a very large industrialized nation, and it wants to reduce particularly its ability to physically interact with the rest of the world for a few hours, to a few hours, which Sabre technology is capable of doing. However, what I personally have seen, and I've not necessarily seen the most recent information, is that the other people have got a long way to go to catch up with us. So China, Japan, America, even some of our cousins just the other side of the channel have still got a long way to emulate the technology that Reaction Engines is now in control of. However, we can't be complacent. If Reaction Engines suffers lack of investment and can't keep the programs running, then other people will overtake it.
Yeah.
So I think that that's particularly important in the context of potentially the UK pulling out of Europe.
Yeah, and I was about to suggest that is that something that keeps you awake at night, particularly considering the background that you've had with the British government, especially pulling out of projects. It seems to me that your entire life is a story of a project getting so far and then governments losing their nerve almost. Is it something that keeps you up, that somehow that the Sabre won't get over the line purely because of a lack of nerve?
First of all, I have to say that these days, with the help of a well-known amber Scottish liquid product, there's very little keeps me awake at night. But yeah, the things that I have anxiety about from the point of view of benefit in the UK is that I would like to see us more enthusiastic as a nation in looking at what Reaction Engines is doing and pushing that product much, much harder by the company. Is almost a sort of biblical tale of having to go and forage for its own straw and clay to make the bricks, whereas other nations where the governments have got a rather different ethic with regard to the funding of projects of national importance don't have that impediment. So I would like to see at a national level both national investment but also schemes to encourage wealthy organisations, wealthy individuals, etc., to put their money into not just products like the Sabre, but right across the board. Electric cars, the automotive industry, the wider today aerospace industry in the UK. If we're going to compete on a future market as an individual nation, then I think that there's got to be a lot of soul searching within government, and in particular within those parts of government which look after the interests of industry, in order to make us. It's not a question of being competitive. We've got to be out there on the forefront with cutting edge technology that the rest of the world's not actually woken up to yet. Once you get into a competitive situation, I think there's a long history with Britain and its inability to compete on a level playing field. So the car industry is a case in point. We're only going to, in my view, succeed if we have products that other people don't actually have. Whereas if we get into a sort of slogging match of seeing whether we can produce our ordinary vehicles cheaper than the Chinese or the Koreans can produce their ordinary vehicles, I don't think we'll win that competition. It's not in the British culture to actually succeed on that field. Where we do very well, and in the past it's been despite government and not because of it, is when the innovative people in this country have come up with something new. Radar, jet engines, supersonic aircraft. Not so much in the rocket propulsion. We were rather sort of behind the chase in that. But nonetheless, I mean, we do have a very good record of being out there with a large number of products first and then letting everybody else overtake us. So I would like to think that will change. That does give me anxiety, but as I've said, few things actually keep me awake anymore.
So I mean, because that does play into Brexit, doesn't it, in terms of it do you think, is Brexit either, no matter which way it goes, is that something that has an effect on something like Reaction Engines or other companies that are in the UK?
Fortunately, most of the support for Reaction Engines has come via the European Space Agency, via the UK government through the European Space Agency, but also through predominantly UK-based private and institutional investment. And as such, Brexit, in whatever form directly, shouldn't actually influence that, because the European Space Agency is not actually a European institution. And so you've got people like Canada, for example, involved in the European Space Agency. Having said that, then I think that unless we have got something extremely innovative to offer, and that is enjoying support back home, I cannot intuitively see that other nations will be enthusiastic to support it if it's not attracting support back home. It's something that the various nations of Europe have always had difficulty understanding about the Sabre engine, for example. If the Sabre engine is such a bloody good idea, why isn't the UK government actually supporting it in a much stronger fashion? With regard to the actual process of coming out of Europe, I don't feel that the answer to that is simple. I have my own views, but I won't voice those. But there are obviously, we're either in or we're out. If you can't belong to a club, leave it and still expect to have all the same facilities that you had when you were part of it. I think that's a non-starter from square one. If you're going to leave a club and then essentially compete with the role that that club has set itself, then you've got to have some very, very clear ideas and determination to make that work. So if we come back to good old Blighty in the context of leaving the European Union, then I can see that there's tremendous talent in this country. And I can see historically in the past that we've done very well at that. But what I don't see at this moment in time is all of the surrounding decisions and systems being put in place to support a lonely Britain out on its own, outside of that union, to then go into competition with it. So I can't remember exactly what the size of the European Union is now. It's over 300 million sort of people. It is the biggest trading market on the planet. We are going to pull ourselves out of it, and somewhere, some of our politicians believe that we've got some magic up our sleeve that's going to enable this island of sort of well, in terms of the actual production side of it, maybe 50 million on a good day, to actually compete with this larger organisation. I myself can see that the European Union has got a lot of failings within it, but I don't really believe that you solve those failings by actually removing yourself from the process. So I'm very open to whatever the options are going to be. I do wish we'd just take the Korolev attitude and say, for God's sake, stop mucking about and go and do it, whatever it is. Whatever they're going to do, it is
down to leadership, it's down to political leadership.
Absolutely.
And whether we're going to get that. And as you say, if we look at the current situation, it really doesn't look like we're going to get that anytime soon.
No, we're dithering and mucking about and full of indecision and debate instead of somebody. I always come back to Korolev because my view is that Korolev was never really a very great engineer, superb in terms of his interest and motivation to put the Soviet Union into space. And he was a good engineer. He wasn't a great engineer. Glushko was a much better engineer. And Glushko and Korolev were sort of daggers drawn at one another. But Korolev just had this ability to say, stop mucking about and go and do it. Somebody would sort of say, but if we didn't, he'd say, I don't want to know. That's what I've drawn. Here's the picture. Get it drawn up and get it in the factory.
Yeah, I kind of get the feeling that Musk's probably a little bit like that.
And so that's why I drew the comparison earlier. I think that Elon Musk is very much like that. And I myself was astounded when I saw the recovery process they were going to use on the Falcon 9, because before they actually announced exactly how they were going to do it, I did my own mission and propulsion studies and so on. And over the years, I've become convinced that the way you get your first stage back is put wings on it and a small jet engine and fly it home. Dump all the propellants so that what's coming back is relatively inert, except for a few litres of kerosene for the flyback engine to get the stage back. And then it lands on an undercarriage. And there was, back in the 1950s, a program called the X-10, which was the flight test vehicle for the Navajo missile. And even back then, you could fly a vehicle, automatically return it and land it. The Russians did the same with the Buran space vehicle.
Which makes it even more astonishing that STS-1, flew with human drivers. We could have a long discussion on that.
Absolutely, yeah.
Yeah, John Young.
But I was astounded that it came back that way. But Musk is my hero. He's basically said, I've got a lot of money. I've just bought an out-of-date aircraft factory. I've done a deal with the US government over the access to the fast-track technology on the Merlin engine. Go and do it. Make it all work. And those
again, it's leadership, and it's almost as if he's a kind of benign dictator within his sphere.
So one of the...
Or not so benign.
Well, maybe not. Yeah.
In trying to work out how he's done it for the claimed costs, which I already said I can't explain. Nonetheless, I think that within SpaceX that somebody's given a job to do, a bit like the old Soviet Union. Just go and do it. The money's there. I'm not going to be sort of waggling about. I'm not going to stop it part way through because you've run over budget. You just go away and you do it. And it will cost what it costs. Because another thing that irks me quite a lot is that there's some project. And at the start of that project, somebody's done some calculations on what they think it's going to cost. The project finally costs a certain amount of money, and everybody says, oh, it was a cost overrun, etc. No, it wasn't. The people did the cost estimate to start with got it wrong. Things cost what they cost. And then to find that the costs are going up and then have a stop start sort of attitude towards it while we stop and review the costs. And this is what British governments have done over the years, especially since the 1960s. We've started so much stuff. HS2, please, Mr. Korolev, what would your view be? Just go and do it.
Well, yeah, and SLS. I mean, you could
SLS. Yeah. So
it's not. Yes, it's a disease that goes. Can I get really nerdy?
Yeah.
I've been reading a book quite recently called Ignition, which is a book that got republished. And it's all about lots of different types of rocket fuels, basically the hunt for the perfect rocket fuel. And I know that you spent your time when you worked for the Ministry of Defence, you were spending a lot of time, your own personal time, on computer time that you'd managed to
correct
to get working on looking at basically your own personal research into ignition types and launcher types.
Yeah.
Is there any really great insights that you've got from that? Other than finding out you couldn't have single stage to orbit.
So there's an old phrase about horses for courses, and I think Elon Musk chose pretty much the...
There we go.
Just gets better and better, doesn't he?
Listening back to that, I forgot how many just ridiculous things there were in there. So good.
The name's Bond. Alan Bond.
The name's Bond. Alan Bond.
We haven't had Space Word of the Week, but have we got Space Fact of the Week?
We have got a little space fact of the week.
Oh, let's finish on that then.
Yeah, I really like this one because one thing that I've set up for my own students next term is to teach them how to solder. For our American or Canadian listeners, that's solder, I think they call it. I know, it's weird because it's got an L in there, but they call it soldering. But it's soldering in Europe and Britain. But yes, ESA have actually got 7 certified soldering schools across the continent. So one in Italy, France, Germany, Denmark, Switzerland, and here in the UK, and a further school on its way in Poland.
Oh.
But these schools are so good at teaching people soldering that they've gone on to sort of work for all these other companies. So all your Formula One companies and people like that are sending their peeps.
No way.
People from Argentina and Malaysia and the United States are all going to these soldering schools because it's the ultimate soldering accreditation you can get.
Well, I could do with some of that because I had a leaky sink the other day. I might not have needed those skills, but I mean, what a hell of a job it would have been.
Who you want is Ernst Messerschmitt.
Yeah, that's true. Actually,
to come round and fix your sink. Legend. But no, it was soldering, because of course soldering is mega important on ye oldie satellites.
It is.
Because you don't want them breaking with your dry joints and stuff.
No.
And you got to keep the tip of your soldering iron. You got to keep that clean. You got to keep it clean so you don't get any contaminants to make your dry joints later on.
Keep it
that's all you need
clean.
to do. Nice
Make
and,
your satellites
nice and clean,
mean.
well tinned. There we go. So Jamie, what do you think about that?
Well, I love it.
I'm quite excited about it. I want to get myself on one of those courses.
Well, I might just buy one and teach myself. I mean, how hard can it be to solder a satellite?
I love soldering, by the way. The only problem is I grew up when there was lead in the solder, so my teeth went green. My teeth literally went green for a bit because I was breathing in so much lead fumes.
Oh, God.
Which is why I've gone a bit funny. Yeah.
Yeah, it's never left you, has it?
No.
No, that explains a lot.
Jamie.
Yeah.
Shall we say goodbye to the Spodcats?
I'd like to wish them a happy weekend. I would also like to remind them to look up. Maybe take a pair of binoculars and maybe have a look at the moon tonight. See if you can spot any golf balls.
Well, have a look at the moon tonight and think to yourself, maybe we'll be watching television in 5 years' time, extremely excited and rubbing Matt's nose in the fact that he was wrong and that we actually got to the moon in 2024.
Yeah, and that it is made of cheese.
Trust me, I don't care if I'm wrong, and we go to the. It's a no lose situation for me. This one,
Matt. If loving space is wrong, I don't want to be right.
Oh, that is beautiful, Jay.
Yeah.
You old fool.
You silly ass. Matt, just before we go, if somebody's listened to this show for the first time and they've liked our absolute nonsense, what can they do about it?
Well, they can maybe just drop us a 5-star review on their favourite podcasting place, which now includes Spotify, Google Play, iTunes, Stitcher, Acast, all those places.
And Matt, that's not just a vanity product. Does that actually mean that people can help it sort of find the podcast?
That's what it does.
Yeah.
It helps others go, do you know what? So-and-so liked so-and-so's podcast, but they also liked this one. It's come up as a suggestion.
Exactly. This isn't just because we're a pair of peacocks, which, well, we are.
Although I do like it.
Yeah.
I do like it when they say, I listen to the Interplanetary podcast every week and Matt's my favourite host. Jamie's rubbish. Stuff like that. I love it when people say that kind of stuff.
Yeah, it hurts my feelings. But then, like I said to you, Matt, now I'm mindful. I don't let it get to me.
Yeah, you are a beautiful human being.
I just realised that I'm a floating bit of decaying stardust in a tiny corner of one of many bubble universes.
Well, Jamie, all I'm going to say is I hope that if any of you want to sponsor Jamie, you go over to Jamie's little thing that I'll stick in the show notes.
Oh, thanks, Matt. I really appreciate it, and I wish everyone a good weekend. Look after yourself.
Jamie, are you going to film a little bit of footage we can stick on the Patreon feed of you coming over the finish line?
Yeah.
Pardon the expression.
Sure. Yeah, you want me to do that again?
Right. On that one, bye-bye, Spodcats.
Take care.
Have a lovely weekend. Tutty bye.
Bye.